For this particular video, what we're going to talk about is the inverse trigonometric functions. Now, what are the inverse trigonometric functions? The inverse trigonometric functions are, so you have the sine of x, you have the cosine of x, you have the tangent of x, and you have the cotangent and all that good stuff. So the inverses would be the inverse sine, the inverse sine. It would be like inverse cosine. Okay, it'd be like the inverse sine, the inverse cosine. The arc is what we call them. So what do they look like? Um, so the arc sine, the arc cosine, the arc tan. So they're written like this. And then there's the arc cotan. There's the arc secant and the arc cosecant. But what they are, we talked a little bit about them in chapter 7, but we're going to look more at the function. So let's take a look at the inverse sine function. The inverse sine function is, in fact, this guy. Now, we're going to plug that into our calculator in a second, but what I want you to do is I want you to see what's up with the sine function. So if we just look at regular old sine function, if you look at just the regular old sine function, so let's look at the sine function. Now, sine function, here's what's up. If you look at it and we graph it, we know it's a function because it passes the vertical line test. I guess I have to change my window a little bit here. Change my window from, we'll go from 0 to 2 pi. All right, we'll go 0 to 2 pi. All right, so the sine function is good to go. How do we know it's a function? Well, it passes the vertical line test. But we say that a function has to be one-to-one if it passes the horizontal line test. And what I mean is if you look right here, this guy fails the horizontal line test. So that means that its inverse will not be a function. So check this out. I'm going to hit second draw. What am I going to draw? I'm going to draw the inverse of, what am I going to draw the inverse of? Sine. All right, I'm going to draw the inverse of the sine graph. And that's essentially what the arc sine is. So when I draw it, it will come in, hopefully. And here it comes. Now I'm going to open up the window a little bit, and I'm going to go to like negative 2 pi. So you can see, here's the sine curve, and a couple periods of that. And then we'll see the inverse sine here momentarily. Here is the inverse sine coming in nice and slow, nice and slow, nice and slow. And give it time. Give it time. And give it time. So here's the thing. You can't really mess with the inverse sine because it's not really a function. Here's how I'll show you. Let's go back to this. If I graph y equals x squared, right? And I graph that guy. We know that's a parabola, right? Boom. Now if I go to draw, if I want to draw the inverse of that, okay, the inverse of x squared. Check this out. The inverse of x squared, whoops, the inverse of x squared is half of a sideways parabola. So here it comes. Here's the inverse of x squared, right there. But really what it's supposed to be is supposed to be a half of a sideways c. So this passes the vertical line test, but it fails the horizontal line test, which means that its inverse is not a function. So out of curiosity, let's take a look at sine of x, and then let's look at its inverse, which is the arc sine. So second arc sine of x. Now if we look at these two graphs, we can see that here's the sine, and now inverse sine is pretty unique because here's what it does. Let's open our window up a little bit. Let's open our window up to, let's make that -5, -5, make that -5 to 5. And if we look at that now, here's this, and here comes our inverse sine. Why is it weird like this? Why does it start here and stop there? That's a good question. That's a great question. Why does it do that? Well, we know that for a function to have an inverse function, it has to be 1 to 1. That is, it's got to pass the horizontal line test. So what we're doing is, if I take this and I look at this a little bit more, what I want to do is look at this guy, figure. So if you look at this little chunk right here from -1 to +1 in the y, in other words from pi over 2 to -pi over 2, this part right here, the inverse is a function. If I go beyond that, it's no longer a function. It fails the vertical line test. Right? So that's what we're doing. You got to tweak your domain a little bit. So here's what I'm saying. You have to go, all right, the inverse sine is legit. It works if you just think from -pi over 2 to pi over 2. That is, anywhere along where the sine function is going up. Okay? So from -pi over 2 to pi over 2, the sine function is 1 to 1. So the inverse sine has a domain from -pi over 2 to pi over 2. All right? These are the two notations. So the arc sine is true if and only if from if and only if it's 1 to 1. In other words, if you look at it, you can only use the arc sine from -pi over 2 to pi over 2. Anything beyond that is not a part of its domain. Okay? So if we try this, the arc sine of -1/2. All right, the arc sine of -1/2. Well, here you can actually plug it into your calculator, or you can look on your unit circle and say, where is the sine equal to -1/2? Where along your unit circle is the sine -1/2? So if you look at your unit circle, you know that it's a positive. Where's the sine? 1/2 is one of those special angles. I think it's like, is it pi over 6, or is it some increment of pi over 6? So you got to think about where it is. And I believe -1/2 is in where the arc sine is. So that's probably in the third quadrant. Okay, so that's one increment of pi over 6. Which one is it? Let's change that arc sine to, instead of a -1/2, to a half. And if we think about that, we know the arc sine of a half, well, where is the sine a half? That's at pi over 6. So pi over 6 is the answer to that one. How about the next one? What about the arc sine of radical 3 over 2? Where is the sine equal to radical 3 over 2? Well, that's easy. That's at pi over 3, right? How about the arc sine of 2? Well, the arc sine of 2 doesn't exist because it's outside of your domain. In other words, if you look at your graph, you just go ahead and plug it in your graph here, y equals, and we look at arc sine of 2, you can see why that doesn't work. If you plug it in, here is 2, and here is arc sine, and they don't cross. That's why. Okay? And then you see that we had the other one, which was it radical 3 over 2? If we did radical 3 over 2, if you look at the graph of radical 3, like where is the arc sine equal to radical 3 over 2? Well, we already know on our unit circle that it's at pi over 3, but here it's going to come in contact with, and if I go to trace and I punch in pi over 3, and hit enter, you'll see you're pretty much right there. Okay, so it's like right here. Pretty easy, makes sense. Arc sine does not work of 2 because it is outside of our domain. What does the arc sine look like? We just talked about that. So it basically looks like this. These are the values. So when you're thinking -1 to 1 is the arc sine. So -1 is the smallest you can put in. 1 is the biggest, but you can look. You can't go anything smaller than negative pi over 2. You can't go anything over pi over 2. So everything's got to be in between there, if that makes sense. Remember, the domain of the arc sine is closed, so it's basically from -1 to 1, and the range is from negative pi over 2 to pi over 2. That's the highest values you're going to get and the lowest values you're going to get. And you can't go over 1, and you can't go under anything smaller than -1. Other inverse trigonometric functions. Well, here's the cosine. Now, what I did is I highlighted this little black part right here. That's the arc cosine. Now, if you notice, the arc cosine starts at the input of 0, and it goes all the way to pi. That's its domain, and its range is from -1 to 1. It functions the same exact way. All right. Trigonometric functions like the inverse tangent function. Okay, you got to define the inverse tangent function by only looking at your tangent from negative pi over 2 to pi over 2. And if you want to see what it looks like on the graph, all right, so you can clearly see this. If we look at, if I graph the arc cosine of x, if I graph the arc cosine of x, you can see that this guy is kind of like, they're similar. So you can see that you are restricting your domain. It starts and ends here. Let's look at the arc tangent. Let's look at the arc tangent. Arc tangent. Wow. If you take away that arc tangent, well, you know what? Here's the thing about the tangent. It's pretty much, the arc tangent is way different than, the arc tangent is way different than the other ones because it looks like it passes the vertical line test, which it does. They all do because they're functions, but you have to be mindful because if we look at the tangent curve, if you look at the tangent curve, tangent is also not 1 to 1 because it fails the horizontal line test. It fails the horizontal line test as well, and that's not good. So here's the arctan. You can see that horizontally it is not good. So you got to restrict your domain. So if I look at my window, I got to restrict my domain from negative pi over 2 to pi over 2. We've got to restrict that. And if we look at that and we look at the two graphs simultaneously, so here's that. So now that passes the horizontal and vertical line test. And here is the black line, the black curve right here is the arctangent, which works. But you got to just remember that its domain is anything you want, but it can't go past the negative pi over 2 to pi over 2. And we'll talk a little bit more about that in class. All right. So here's a little recap of how everything works. So the arc sine has a domain from negative 1 to 1, range from negative pi over 2 to pi over 2. The arc cosine has a domain from negative 1 to 1, a range from 0 to pi. The arctan domain is anything it wants to be, and the range is from negative pi over 2 to pi over 2. And we're going to wonder why that is in class. Okay, so let's see if we can figure out these values. The arc cosine of radical 2 over 2. On the unit circle do you have a cosine that's radical 2 over 2? I believe that's pi over 4, right? This is supposed to be the arc cosine of negative 1. Where on the unit circle do you have an arc cosine of negative 1? Well, negative 1, the cosine is at negative pi over, or 3 pi over 2. But is that too big? In fact, you can actually use your grapher and graph this. If we do the arc cosine, right, we do the arc cosine of x, and you want to look at where it's equal to negative 1, and we hit graph. Here's the arc cosine, and looks like there's nowhere, because you can't have that, if that makes sense. How about the arctan is equal to 0? Well, we have in our calculator, I think we have the arctan. We have the arctan, and where is it equal to 0? Well, if we look, 0 is right here. So the arctan is equal to 0 at 0, if that makes sense. And then what about the arctan equaling of negative 1? Well, the arctan of negative 1, you can plug that in, and you can see the arctan negative 1 is right here. You can find where they cross, which is probably negative pi over 4. If that makes sense. Okay, so I know this is a long one. Hopefully you're looking at it. We'll do a little bit. We'll go into a little bit more detail in class tomorrow. Good luck, and may the force be with you.